None of these teams had anything. There was no hardware. They were all designs. And less than 1 year later, if you go down this aisle, you'll see 27 pods, fully functional, fully tested, that did an absolutely spectacular job over the course of less than a year. So congratulations to everyone. Some quick thanks. We'd love to thank the City of Hawthorne. They've been an absolute pleasure to work with. We'd love to thank Texas A&M University, who hosted our design weekend last January. Thanks a lot. Thank you to Jerome Horton, Chad Myers, the Mayor of Hawthorne, Alex Vargas, and the Hawthorne City Council, and Phil Washington, the CEO of the LA County MTA, for attending. We really appreciate your help. In general, Los Angeles has been a spectacular place for us to do business, obviously with SpaceX, but also for the world's first Hyperloop. And the Hyperloop's really a step to helping solve transportation issues. And for that reason, we truly appreciate Mayor Eric Garcetti's support, and we are thrilled to have him here. So, ladies and gentlemen, Mayor Eric Garcetti.
Thank you so much. How's everybody doing? So this is what the future looks like. And it is rare in our lives we get to feel that moment. I mean, I know for Elon it's every day, but for the rest of us, it's everybody's dream to be a part of turning the page. And I think that all of us can look back in this city where so many pages have been turned in aerospace and in space and in transportation, in the way we tell stories, the way we connect and communicate. But I want to thank SpaceX for its incredible commitment to this town and to this world, to our local economy. And I also want to thank Mayor Alex Vargas and the entire Hawthorne, my brothers and sisters from Hawthorne. You're an amazing city. I'm just a neighboring mayor. Thank you for the hall pass to be in your town today. Thank you as well. And I want to single out Elon Musk as well, who has been not just a visionary for our city, but obviously for our world, and some would say even beyond. But thanks for being such a great host this afternoon and inspiring us to dig deep into what we think is possible. We just went and saw the beginning of tunneling. Some of you, if you follow his Twitter feed, know he's going to be looking at tunnels. And we want to be there in Los Angeles right with him. And so your Los Angeles MTA is excited to partner and see what we can do to get us home more quickly, to see our kids, or to get to that date or that job interview or that concert without the soul-crushing traffic that we all experience. So thank you for that as well. And I also want to thank Elon on one other front, just because I came from the airport today, and this is an apolitical event, but this is a nation of immigrants like Elon and others who come and are stepping off our planes. And it's important for us to remember who we are and what we're about. Look around and you see the greatest diversity. The face of LA is the face of the world, and we're not turning back on that. But here, with compassion, with grace, and with great brains, we bring a city together that there's no challenge that we cannot meet. This is a town that consistently is reimagining things. And today, we're looking at the very first Hyperloop pods ever. The ones that are the vision for the future of transportation, that you can tell your children and your grandchildren you were here to see. And the incredible design by teams of young men and young women who accepted Elon's challenge, heard his words, read his white paper, and got to work. You dreamt about what was possible. You didn't limit yourself by what was in front of you today. You thought about what could come tomorrow. And that's truly amazing. I think it is a definition of what our town is about, but also what this company represents too. Right here in the cradle of aerospace, SpaceX is helping us redefine what it means to look to the stars with wonder. They're capturing the minds of a new generation, pushing the bounds of engineering and of science, and benefiting so many companies across Southern California and throughout the world in the process. This isn't just a win for any one town, it's a win for all of us as human beings. And the small businesses down the supply chain who can benefit, the folks at the Port of LA who bring in the materials and the parts, and congratulations on another amazing landing, by the way, that SpaceX just did as well. The other day we hosted our first tech job fair in Los Angeles, and we hope to get a couple dozen companies and a couple thousand people. We had 13,000 engineers and would-be employees line up to meet with 275 companies, including Tesla and SpaceX, and other great LA companies that are pushing the boundaries. It's amazing to see that reinvention is alive and well, that for all of us here, We can feel that something big is happening, both in this town and at this moment in history. Here in this town, just a few years ago, we had an unemployment rate that was more than double what it is today. Here in this town, we didn't see people coming to invest or to visit, and we've shattered every record this past year of visitors, of tourists, passengers at LAX, of cargo coming into our port. LA is a place where people are betting big. It's a moment that entrepreneurs also are taking risks to push forward, not just brave new companies like the ones you see here, but keep innovating to solve the problems that we have. Our problems aren't new as human beings, but the way that we're approaching them are. And that's what today is about, to see and to touch and to feel what it means to be an innovator. And for all of you, whether you're lucky enough to be born here or smart enough to just come here today, you're in LA, the home of innovation. In some ways, the cross-section of so many capitals of the world, the northern capital of Latin America, the western capital of the United States, the eastern capital of the Pacific Rim. But today here at SpaceX and with Hyperloop, we are the capital of innovation. Congratulations to all the teams. And with that, let me introduce the visionary who has brought us here today, my friend, a great human being, and somebody who has pushed the boundaries in everything he has touched, the one and only Elon Musk.
All right, I'd like to just add my congratulations. I think we've got 800 students, 27 teams, some of the smartest engineering students in the world. Thank you for coming. Thank you for participating. You've done incredible work. Well done. It's actually quite remarkable to sort of see this in operation. I'd just like to thank Steve Davis and all of the people at SpaceX who have volunteered to do this. It's really been a volunteer effort. So well done, guys. I'm amazed at what you've done. Just give those guys a hand. It's like they really deserve it. So what this is really intended to do is to encourage innovation in transport technology. To get people excited about new forms of transport, things that may be completely different from what we see today, but to really just get people to innovate and think about doing things in a way that's not just a repeat of the past, but to explore the boundaries of physics and see what is really, really possible. And I think we'll find that it's way more incredible than we ever realized. That's really the overarching purpose of this Hyperloop competition. And so we got I'm told this is like maybe the second biggest vacuum chamber in the world after the Large Hadron Collider. So it's kind of exciting. And then later today we'll see how fast the pods can go. And I think it's just going to get better and better every year. I think it's ultimately going to be something that inspires the world and results in real transportation technologies that help people's lives and make them better. And then, as the Mayor Garcetti mentioned, we started digging a hole. There's on Crenshaw, just in front of SpaceX headquarters, there's a giant hole. And I find holes in the ground exciting. I was discussing this with my girlfriend. She didn't find it that exciting, but I thought it was really great. So it's right there. You can check it out. And so that's going to be the start hole for the tunnel boring machine. And we're going to just try to figure out what it takes to improve tunneling speed by I think somewhere between 500 and 1,000% is, I think, possible. So if you apply sort of a limited physics approach, so we'll see how far we can get. So we're just sort of muddling along. We have no idea what we're doing. I want to be clear about that. But we're going to get this machine, figure out, okay, take it apart. How do we make it go much faster? While still being safe and not affecting people on the surface and all that. And we'll see how much progress we can make. But I'm actually quite optimistic that tunneling can be improved by at least 5-fold, maybe 10-fold. and that's really key to a lot of technologies, road tunnels, Hyperloop tunnels, train tunnels, because fundamentally you have to go 3D if in a city. If you've got tall buildings, they're all 3D, and then everyone wants to go into the building and leave the building at the same time. So then on a 2D road network, that obviously does not work. So you have to go 3D either up or down, and I think probably down. So, and then for longer distances, things like the Hyperloop and other ideas. So with that, just once again, congrats to everyone. Amazed at what the student teams have done. Really just blown my mind, and may the best team win. Yeah.
Thanks again, everybody. So what is going to be happening in the next few hours is the team from VAR is right here, and so they're going to do some quick work on their pod. They're going to load it in. We're going to load in our pusher, and then we have to pump down this entire Hyperloop, or I like the one saying one of the biggest vacuum chambers in the world. The pump down takes about 30 to 35 minutes, so there's not a lot of action during then, so feel free to go look at the booths or whichever, and then we will announce when the launch is about 5 or 10 minutes away, and then we can come up and watch, and after that there will be 2 more launches after that. So again, thanks again, and enjoy the event.
As you can still hear, the crowd is very excited, having heard the welcome remarks from our mayor, Eric Garcetti, and Elon Musk, who originally proposed that Hyperloop Alpha paper. Now, quick status update on everything that's happened so far today. We had 3 teams that were slightly out in front who had completed all those prerequisites to get to that 10th and final milestone of entering the Hyperloop, as you heard us mention before. Now, MIT did their vacuum down 10th run through the chamber earlier today. So MIT has done that, but we have 2 other teams in the pipeline who are getting ready to do so soon. And that is War just thereafter, and then Delft later on in the afternoon. We'll try to bring you coverage of both of those live as they happen. Now, just to set expectations, MIT went about 80 kilometers per hour. We expect War, who will follow, and Delft to do very, very similar things. But again, as a reminder, this is a student competition with student pods and student results. There might be some starting and stopping. There might be some going and braking. We're going to get you that live as it continues to happen. So we had a chance earlier to speak with War and talk with them about their Hyperloop design for the pod itself. We're going to show you the clip of that now.
I'm the team captain of the VAR Hyperloop team and the German participant of the SpaceX Hyperloop pod competition. We are from the Technical University of Munich in the great state of Bavaria, and we started this project around September 2015. So actually a few months after the competition was announced, because we had to get a team together before we could do anything. So our initial design, we had a very sketched up preliminary design around November 15, which we then sent to SpaceX. But of course, if you compare that design to the pod standing back behind me, you will find very few similarities because basically everything changed between then and now. But 1.5 years later, we have a Hyperloop pod standing behind it. So yes, the big difference in our pod from most of the other teams is the big compressor that we have in the front. We actually had it in the beginning, so a compressor in the front is probably the one similarity you will find between this design and the one we had in November. But even the compressor has gone through different stages. The compressor, in theory, is actually a very important part of the Hyperloop concept, because the big difference from the Hyperloop, the big innovative thing in the Hyperloop concept is that you still have some air inside of the tube. What the compressor does is that it sucks this remaining air in the tube so that it can pass through the pod and even have an air duct for that. And it passes the air through the pod and expels it to the back. This allows the pod to be quite bigger in comparison to the diameter of the tube, which is also one of the reasons why we have one of the higher pods. Why Hyperloop? Because it's awesome, because it does have the potential to change lives. I think the transportation problem is one of the biggest problems that you still need to solve in the next century. and the Hyperloop is a hell of a first step in that direction.
So we said there's 31 teams here actually at the competition. 4 of those teams are just exhibiting their pods. They didn't get those pods completed at the state that they were actually ready to begin the tests that we require the teams to participate in. 27 of those teams began the process about a week ago of going through what we had was 10 milestones that they would need to complete in order to say they were completed the SpaceX Hyperloop competition. These milestones were incrementally more difficult as the team at SpaceX assessed the pod's capabilities and made sure that they were ready to put them inside this chamber. We wanted to make sure that these pods themselves were going to be able to run and not cause any harm to the chamber, to the pods, to our pusher, or anybody else around, and also give these teams the best chance of succeeding. So our SpaceX team directly worked with these engineers here, these students and up-and-coming engineers in their competitions. Of the milestones the teams had accomplished, the first of which was the safety briefing. This is really less of an opportunity of us to tell the teams safe instructions, but it's more of a chance for SpaceX and the teams to have a discussion of the different hazardous pieces of their pods. Levitating a few thousand pounds with magnets require a lot of magnetic force and can become very difficult, and it can have some hazards associated with this. So we need to be monitoring those situations. A lot of these teams use a very large compressed gas cylinder, something like a scuba tank on board, to use those air-bearing skis. We need to make sure that those pressurized cylinders themselves are well handled and they're not going to pose a hazard to the competitors. So we want to make sure that these teams are testing safely and are going to be competing safely. After that safety briefing, we start meeting with the teams and do a structural inspection. That's really the opportunity where we're going to ensure that there's no damage during transport and that basically the pods themselves, the primary structure is very sound. Any of these pressurized systems, these high energy components themselves are well controlled and contained, and also that the fasteners themselves are all torqued and indicated and are all together. Once they pass the structural inspection, we'll move into bringing the pods online. These are actually very intelligent vehicles. On board, there's flight computers, there's telemetry, there's sensors, and we're making sure that all of these sensors themselves are functioning and are going to operate. Most importantly, we want to validate that the communication systems are functional on these pods, that once they go down that tube, that big metallic Faraday cage where you can't get any Wi-Fi signal through or any radio signals through, that they're able to communicate with the SpaceX network access panel. Along the tube or on the top, we have a coaxial antenna. That's how the pods within the tube are transmitting their telemetry and data to the network access panel, that then the teams have their own user interface that they're able to see their pod's telemetry and command things like braking and whatever that they may need to do. So we're verifying that all these things are functioning, and most importantly, things like the emergency stop is working. Once we complete that functional test, we move into mechanical fit check. It's pretty simple in that one. We just want to make sure that the brakes are going to align with the necessary pads on that aluminum subtrack down the center. Once those brakes are aligned and we know that they're going to be able to stop and that the pods themselves are going to fit in, not going to have any issues, we move them into the vacuum chamber. Now, this is one of the most hardest tests, and Brian's going to talk in a few minutes about why vacuums are so challenging. That's that vacuum chamber on the screen right there. When the teams go into that vacuum chamber, we actually close that door. It's really a small subsection of the larger Hyperloop track, and through that center, we actually bring the pressure down to a comparable pressure that they would see inside the chamber. Coming from a space engineer myself, vacuum is a very hard environment to work in. Things like batteries and a lot of things with fluids and pressure systems can have some issues in a vacuum environment. So we want to make sure that when the teams in those vacuum environments don't run into any problems. So we do that checking there, make sure they can command their vehicles again, make sure they can depress as necessary, pull those emergency stops, and the brakes are still functioning. From the vacuum chamber, we know that we're incrementally working up in difficulty in the systems. We move them into a navigation test. It's a litany of testing. Engineering is all about testing. Navigation testing is where we want these pods to provide accurate telemetry of the position of their pods. We want them to make sure that they know exactly where they're at on that tube. It would be a really bad day if the team thought that their pod was 100 meters further along than they actually were, or 100 meters further back along the tube, and they think the exit was actually earlier than it was, or the exit worst case would be later, and then it could crash at the end of the tube. So we want them to verify that when the pod is just stationary, that there's no navigational drift over about a 5-minute period. And we're also going to review the team's graphical user interfaces, our GUIs, and make sure that those GUIs are providing them accurate telemetry data. From that navigation test, we're going to move into a state diagram test. Those are for those software engineers out there. That's where our software team is going to sit down with them and going to basically review through all the logic steps that go into building the pod's software and flight computer states, and really making sure that in those things that the pod itself will not apply braking inadvertently. It'd be a really bad day if once that pusher, the SpaceX pusher, goes and accelerates that pod forward, if the pod decided to just clamp on its friction brakes inadvertently, that would potentially damage the pod, and it could also damage the SpaceX pusher. So we want to make sure that that pusher you see on the screen there is able to execute and provide its motion. And you can actually see that SpaceX pusher on your screen right there with the frame and those wheels, and our engineers there are they're debugging and some of the earlier testing we have there. We provide this pusher a profile as it accelerates the pod, and we're making sure that the teams themselves don't run into any problems there. From that testing, we move them to the external subtrack. That's actually what you're seeing on your screen right there. That is the external subtrack. It's just adjacent to the competition area we're at right now. Basically, that's a 150-foot open-air test outdoors, where we actually are going to use a second pusher, and we're going to be pushing the pod along that track, and that's the chance for the teams to show all these systems that we previously had them demonstrate can work in sequence, that they can get a command from the pusher, accelerate the pod forward, and then apply the brakes and really brake at that moment in time. Once they verify that, once they've gone through all these other litany of tests, we then move into the open-air Hyperloop test. That is actually the first time these teams enter inside the Hyperloop tube chamber. It's actually a very exciting moment, I think, for all these teams to see their pods get forklifted up onto the loading platform, get that door closed. Now, we don't depress in those events. We just want them to verify that everything still works. We don't make them go in a vacuum for the first time, but this is the time when they actually get to run down that first 1.25-kilometer long track and get some test runs in there to see and validate their aerodynamic models, their friction models, and everything to see if their pod is performing as they expected, and they can calibrate the target speed they want to run for the actual Hyperloop run. And that is where we're at today. 3 teams today are coming into the tube, where SpaceX is going to initiate the pusher testing. All of these tests have led at this moment where the teams will depress into the vacuum, and that's what we're waiting on right now, as a matter of fact. We've probably about another 15 or 20 minutes as the main Hyperloop chamber is continuing to get depressurized for War Hyperloop to enter into the tube. And while that depressurization is continuing, the War Hyperloop team is doing their final checks on their vehicles. So it's very, very exciting right now. MIT is finished, War Hyperloop coming up, and in about another hour or two, we'll have Delft Hyperloop coming up. I talked about all those tests. Probably one of the hardest ones, and what's going on right now is the vacuum chamber. So let's check in. Brian knows a lot more about vacuums. He's also a space engineer. So he's going to fill us in about some of the complexities it is working with a vacuum environment.
Thanks, JFed. Now, as you can see behind me, VAR, or War from Germany, that team is about to enter their pod into the Hyperloop itself. After that moment, we're going to depressurize the chamber, and that takes about 30 minutes. Now, you've heard this said a couple of times, but once you enter that vacuum environment, it introduces a few complexities that you maybe did not design for. Now, in order for me to be able to describe what the difficulty of a vacuum is, first an understanding of pressure is necessary. Now, people understand what pressure is in the sense of water, of fluids, because at the bottom of the ocean, they're going to feel a certain amount of pressure, and the reason that you feel that pressure is because you have a litany of fluid above you. You are piled on top of by a ton of water, and because of that, you feel a pressure. When I'm standing here on the surface of the Earth, that exact same concept is happening, but instead of with water, it's happening with air. Our atmosphere is filled with the fluid, it's filled with the gas, and that gas is air, and although it is much less dense than water is, it is still an ocean of substance above me, which is weighing down on me. Now that creates a pressure, and so that's the atmospheric pressure that we all feel, and that's the atmospheric pressure that these student teams have all designed their pods to sustain. However, once you remove the external air, you remove the external pressure by pulling a vacuum, you suddenly remove that pressure from the outside. So if you can imagine I have a small computer or a printed circuit board or something on board these vehicles that was designed to contain atmospheric pressure, it has atmospheric pressure pushing on the inside of that box, atmospheric pressure pushing on the outside of that box. Well, it's an equilibrium, and so it's happy. It doesn't feel a net force. If I take that box and then put it inside of the vacuum chamber and suck out all the air on the outside, I still maintain the internal pressure from the inside, but the pressure from the outside is gone. I no longer have net equilibrium, and I undergo stress within a mechanical components that may not have been designed for it. It's the same sort of situation where if I apply pressure to something, I'm pushing on it. If I pull vacuum something, I'm still stressing it by pulling instead of pushing. So that's one of the complexities that operating in a vacuum environment, these teams are about to experience. So again, we're about to step right into that. One other sort of tangential problem that a lot of teams face is that under vacuum, there are no air particles around to conduct heat away from your vehicle. You don't have a mode of transfer to cool down when your boards are whirring up and you're starting to accumulate heat. You have no means to dissipate that. So oftentimes, electronics and other sensitive devices will start to heat up having been inside a vacuum for a significant amount of time. So that's what a vacuum is. That's what Team War is about to enter. Now, we had the chance earlier to speak with War as well as every other team in this competition to compose a mosaic of 27 different individual bits where we got the chance to have each team describe the pod that they designed, what they expected from it, and their enjoyment along the entire design process. So let's tune into that now.
We're Delft. We're from the Technical University of Delft from the Netherlands. The vehicle we use is completely frictionless. We use permanent magnets both for levitating and for braking. We love Hyperloop because we want to make a global village, connecting all the cities in the world, making everyone connected.
Our team name is the Bayou Bengals. We're from LSU in Louisiana, and we're using magnetic levitation, Arcpax hover engines to lift our pod off the ground. We are working on Hyperloop because it's the future.
David Hyper, we're from RMIT University in Australia. I'm the only one in the Southern Hemisphere. Our pod design is wheels. And the reason we chose Hyperloop is because a lot of us are from country towns. It will make travel a lot easier for all of us.
Hi, we're Team Codex. We're from Oral Roberts University in Tulsa, Oklahoma. Our pod is a magnetic levitation design, and it also has wheels for lower speeds. We're really excited to have the opportunity to create new technology and be on the cutting edge of transportation, and we think that the Hyperloop competition is a really good chance for us to improve people's lives and help people get places faster.
Hey, we're Hyperloop Fabrication Tech. For our pod, we use magnetic levitation, magnetic braking, and magnetic stability to go down the track. The reason we chose Hyperloop is because it's an exciting and new form of transportation that may eventually change the world someday.
We are Hyperloop UC, all the way from Cincinnati. The pod you see at the back uses magnetic levitation to levitate. As for why we are here at Hyperloop, we love to make things real, from dream to reality.
We are NYU Hyperloop. We're from Brooklyn, New York. We've got a test pod here that is for wheels only, and we're developing for Hyperloop technology because we believe in Hyperloop as a sustainable transportation solution for the future.
Hi, we're a Purdue Hyperloop design team. We have a passive magnetic levitation pod. Why Hyperloop? We're looking for a new green energy transport system. We like stuff that goes really fast.
Hi, we're Badgerloop from the University of Wisconsin-Madison. We have magnetic levitation and also magnetic propulsion. We're really excited about the Hyperloop idea because we believe it's going to revolutionize transportation, and hopefully one day our children will use it to move from city to city.
We are MIT Hyperloop from the Massachusetts Institute of Technology. Our pod design focuses on magnetic levitation. And why Hyperloop? Well, we're really excited to be working on a completely new form of transportation, something nobody has designed or built before. It's a massive challenge, and challenges is what we like to do at MIT.
Hi, we are Team Hyperlinks. We're from the University of Colorado, Denver. Our pod design is a wheel design up to 300 miles per hour. We're doing the Hyperloop because it's a fantastic opportunity for students like us to really get our hands dirty in an outside-the-box project from start to finish.
We are HyperExcite from the University of California, Irvine, and we are using air-based levitation. We're supporting Hyperloop to promote the future of affordable and sustainable transportation.
Hi, we're B-Loop from the University of California, Berkeley. Our pod design uses magnetic levitation and wheels, and we chose Hyperloop because we thought it was a cool idea and no one's ever done it before.
Hi, we are KO Alpha. We are from KO University, Japan.
we are making a magnetic levitation pod for this Hyperloop competition. And what we love about Hyperloop is we want to be part of the revolution where we can invent the next high-speed transportation system in this century.
Our name is Lehigh Hyperloop. We are from Lehigh University on the eastern side of Pennsylvania. Our pod design uses air bearings fired from a compressor. We use electric motors to pull ourselves forward. We wholeheartedly believe that Hyperloop could be a upcoming transportation system for freight and public purposes. And 720 miles an hour, who doesn't want to go that fast?
We are Gatorloop from the University of Florida. Our pod uses wheels, and we got into the Hyperloop because this is the first time it's being done. We are literally building a pod for the first Hyperloop.
Howdy, we are the Texas A&M Hyperloop team. Our test pod uses air bearings for levitation, and we like Hyperloop because we want to be part of the future. Giga.
Hello, we are U-Washington Hyperloop from the University of Washington. Our pod utilizes a maglev suspension system and a maglev propulsion system, and we are interested in Hyperloop because we want to see the future of transportation.
Hi guys, we are Hyperloop. We are a team from Reddit. We are covering every continent from the world with people from every country basically. Our pod is using active magnetic levitation. We are geeks from the internet. We like everything that is sci-fi, next gen, and Hyperloop is so 21st century. We wanted to be part of it.
We are Team Openloop. We are an alliance of 6 schools coming from Northeastern, University of Newfoundland, Cornell, Princeton, University of Michigan, and Harvey-Mudd College. Our pod design is based on pneumatic suspension. We basically use 2 skis that are air bearings. Hyperloop is all about connecting people and making the world a much smaller place. Just imagine being able to go from San Francisco to LA in 30 minutes. The world's going to become much smaller and people are going to feel a lot more connected.
We're UMD Loop from University of Maryland. We are a maglev design team. We are interested in doing a Hyperloop because we want to be part of an innovative engineering project that helps make the world a better place.
We're Waterloop. We're from the University of Waterloo. We're using Aircaster pneumatic levitation. We've got magnetic eddy current braking. Overall, we want to see the Hyperloop come to light, and I think the Hyperloop's a great technology to connect people from around the world, so hopefully this weekend we can get in the right direction.
We are Illini Hyperloop. We're from the University of Illinois, and we have designed and built a magnetic levitating pod. And we are doing Hyperloop because this technology will be used all across the world in the future.
We are Hyperloop at USC. We're from the University of Southern California. Our pod is a wheel design, and we love Hyperloop because it's the next form of transportation.
Hi, we are Carnegie Mellon Hyperloop. We are from Carnegie Mellon, Pittsburgh. We have designed a pod that relies on magnetic levitation. We use passive magnets to do that, and all of us are super excited about this project because Hyperloop is the future of transport.
Hi, we are the VAD Hyperloop team from the Technical University of Munich. We levitate our pod with passive permanent magnets. We really like the Hyperloop project because it's an excellent way for us to actually do some hands-on practical experience of everything we learn inside of the lecture halls.
We are Team Hyperlift.
And we're from St. John's School in Houston, Texas. We're an air-bearing team.
We chose the Hyperloop because we think it's the future of transportation. We can't wait to see where it takes us in the future.
Now, quick update. Back at the entrance to the Hyperloop test track, where Ward, the team from Germany, is now inside, made it to the pusher, currently undergoing the evacuation so that the chamber becomes very, very low pressure. Now, a bit more on the pusher, the SpaceX vehicle that sits behind Ward Hyperloop right now. Now, a lot of these pods require extreme complexity to design. One of the most critical components that takes a long time to design is a self-propulsion system. Engines, we use rocket propulsion at SpaceX. Propellant systems are difficult. Things to make you go are hard. So in order to help teams focus on the innovation of the pod design itself, SpaceX, in hosting this competition, offered what we call the SpaceX Pusher, which is a vehicle that sits behind the student team's pod and brings it up to speed. Now, this Pusher is a pretty sweet vehicle in and of itself. It's essentially 2 Model S engines, not 1, but 2 full Model engines on a stripped-down race car frame so that it is small, it is lightweight, and it is very powerful. Now, this SpaceX Pusher can go up to speeds in excess of 300 miles per hour. We will not be going that fast today in this student competition on the Hyperloop test track, but it is a very, very capable vehicle. Instead, we intend to bring vehicles up to around 80 kilometers per hour, maybe a little bit more, so that they are at speed that they have designed for, at which point the SpaceX Pusher sitting behind the pod will detach and allow the pod to continue on coasting, performing nominal checks, making sure that it's healthy and phenomenal, and then braking of its own volition. So that's the role of the SpaceX pusher in the entire sequence of events. Now, as this chamber depressurizes and evacuates, that process takes about half an hour. So we're going to wait a few moments until we return, and we'll be able to cut live footage of that. But in the meantime, Jay Fed, my co-host, is standing by with the team from Purdue. Now, it's very, very easy to forget across the pomp and decoration of these competitions that these are real engineering problems. Student teams are handling and solving very, very hard problems. So Jay Fed had the chance to speak with Purdue about their experience throughout this whole procedure.
Hey, I'm here with Richard. He's the project manager of Purdue Hyperloop here today. Richard, how's everything been going so far for you guys in this competition?
Everything has been going really well. It's been a lot of fun, a few challenges, but otherwise it's actually gone surprisingly well.
How far did you guys get so far in the testing?
So we did make it into the tube. We had our first run last night, just a low speed, 35 miles per hour, but we did make it into the tube. Not an evacuated run yet, but we made it pretty much through most of the checks. Just good to go at this point.
Awesome. Did you guys have any particular tests that kind of held you back a little bit or hurt you?
Yeah, definitely. Bringing a pod out here a few thousand miles over to California, a few things can go wrong. So it took us a while just to get through our functional tests, make sure everything was working and did what we said it would and what we thought it would. But once we got through that, we kind of knocked out everything, like the vacuum tests and the low-speed track, fairly quickly.
Any tests that any particular challenge for you, or everything kind of as you expected so far?
Always avionics, always a good challenge with avionics, making sure, the electronics always works. It's always fun.
I know for myself, same kind of problems here at SpaceX, so just making sure everything falls into place and all the buttons,
absolutely,
commanding it.
Luckily, we have a couple of really dedicated good guys on avionics made it come through in the last minute, so they really stepped up. So.
That's awesome. Of the other teams that you've come here and met from all over the world, I'm sure, any pod or any other team that really stood out to you?
There's a lot of really good ones. I really like the look of the Munich pod, so War. That was a pretty cool pod. I enjoyed that one. And then UC Irvine. Really like the composite work on their shelf with that.
Awesome.
But there's quite a number of really cool pods out
there. I see your pod here itself. What's the frame itself made out of?
So we have a full composite structure. I think we're one of the only pods with a fully composite structure. It's carbon fiber. It was a full wet layup. Took many hours. But largely composite carbon fiber layup with just a little bit of aluminum here and there to support various
And did you go for a wheel design or air bearing, or how did you?
So we're using passive magnetic levitation. So we have low-speed wheels. Will get us up to about 20, 30 miles an hour. And then after that, the magnetic skis kind of take over. We get a little bit of lift, and we just ride on that at the higher speeds.
That's awesome. What is your top speed you guys are trying to actually hit in the tube? What was your goal?
We would love to hit 150 miles per hour.
Okay.
Originally we designed for a little higher than that. It turns out wheels are kind of hard things to get going. Lateral stabilization wheels. We had a roller coaster company design them. They capped it out at 150, so we might be able to push it further, but that would be up to you guys letting us go that fast. So.
Awesome. Very cool. Yeah, how big of a team did you guys bring out here, actually, too?
So we brought out, just for the week, we brought out 7, just to keep it not so confusing. Our team has gone from anywhere between 40 all the way up to about 60 members, and then down in the last few months to about sort of 20 dedicated souls.
Very cool. We're definitely very excited to have you out here with us. Yeah, it's very good. So we're going to go right now and check back in and let you guys see the rest of the Hyperloop competition for Wide Shot, and we'll be back in a few minutes with War Hyperloop's Hyperloop run.